Hello and welcome to the TelecomTV Summit on the Green Network. I'm Guy Daniels, Director of Content, and coming up now is our discussion on measuring the energy efficiency of telecoms networks. Just how much energy is consumed by telecoms networks, and how does this compare with other sectors? Which parts are less energy efficient than others, and what efforts are underway throughout the ecosystem to reduce energy consumption levels? Well, let's find out what our guests think, and I am delighted to introduce Saima Ansari, Senior Partner Manager at Deutsche Telekom and also NGMN Project Co-Lead for Green Future Networks, Vivek Gaura, VP Network Engineering at Colt Technology Services, and Azeddine Gati, Green IT Networks and Energy Efficiency Engineer at Orange. Hello everyone, good to see you all. Thank you so much for taking part in this discussion today. So my first question to you is, what do we know about the energy consumption of today's telecoms networks? Azeddine, how much energy is actually consumed and how does this compare perhaps with other sectors?
Very good question. First, thank you, Guy, for giving me this opportunity to participate to this event. To respond directly to your question, energy consumption of the telecom network is estimated about between 2 and 3% of the total consumption of the total consumption of the world, of all the sectors. This is in energy consumption. However, if we express this in terms of GHG, the greenhouse emissions, it is about, there are different studies, but it's estimated between 1.5 and 2% of the total GHG emissions around the world.
Thanks, Azeddine. Vivek, are these figures, the same as you're seeing at Colt? How do you know how much energy is consumed by telecoms networks, and how this compares?
Well, thanks, Gay. But I think the point is we are living in a global context, and Guy, the measurement of telecom per se is very difficult because it's geographically spread, different dimensions. But I think if we zoom out and look at the overall telecom industry geographically, globally, I think Asuddine's point is pretty valid. We are ranging around 1 to 2 and 2 to 3%. Although we come under essentially we come under the industry umbrella, right? So industry has big contribution from manufacturing, it has big contribution from mining, and then we have chemical industry, paper industry, all of them are contributing significantly. And in comparison to that, I think telecom industry is fairly smaller in the context, although not insignificant, and hence this discussion is pretty valid because we need to waymark and see how we can contribute positively because we do contribute in the carbon emissions.
Yeah, thanks, Vivek. Azeddine.
Yeah, I want just to add, to give you a reference. I said that the total consumption is between 2 and 3%, including manufacturing, usage, and the end of life. If we want to give a number, to compare, the total consumption of cars, private cars, is estimated by the International Energy Agency in 2020, in their report issued in 2020, about 17%. Okay, so ICT including devices, networks, and data centers, it is estimated between 2 and 3%. If we take only the portion of networks, only networks, it is really less than that. It's less than 1% of the total GHG emissions. The confusion that everybody is doing is the mix or the confusion between, let's say, the GHG emissions, which is expressed in CO2 equivalent, and in terms of energy consumptions, which is expressed in kilowatt hours. So there is sometimes a confusion between the two, but let's say it's about something between 2 and 3% of the total GHG emissions around the world.
Well, I think you both touched on this. It's so difficult to determine exactly what we're talking about, and we've got to be very careful with our comparisons and how we measure. So this whole issue of measuring efficiency in the green networks, this gets to the nub and the very heart of it. Saima, we've heard about the comparison between telecom and other sectors in terms of carbon emissions, but we also have a role in reducing their carbon emissions. So how can we actually go about measuring it?
Yeah, and I think this is one of the privileges of working in this sector, that we are not the ones who are only, let's say, creating the carbon emissions, but we are also the ones who are enabling our customers to reduce their emissions. And I think this is one of the best parts of being a part of this industry. When we look into the carbon footprint, so we are all aware of this concept, and the exact opposite is something which we call as carbon handprint, which gives us a kind of indication of how much carbon emissions have we saved based on the solutions or the products that our customers are using. And some of them are also calling it as an enablement factor, which is more like a ratio between the amount of carbons emitted by providing the ICT solutions to the customers as compared to how much they can save by the usage of our solutions. And if we look at the overall sector, ICT sector, this factor ranges somewhere between 4 to 10. And giving you a concrete example from Deutsche Telekom, for example, if we look back into the figures from 2020, if we calculate the total carbon emissions from our company, so which is from scope 1, 2, and 3, we have somewhere around 5 million metric tons of carbon emissions, which we have emitted. And based on the solutions that we provide our customers, they were able to save somewhere between 35 million metric tons of carbon emissions, so which is actually a factor of 7, which means that the enablement factor which it gives us is 7 to 1. And I think that this is one of the best examples how we can actually communicate also to our users the fact that how much carbon emissions we can save. And when we look into further analysis of how we measure it based on which services, I think there is no surprise. One of the top levers that we can pull here is the web conferencing. So the most carbon emissions were saved by using that, followed by the mobility.
Great. Thanks for that information. Concrete examples such as you've given us there from Deutsche Telekom, always useful to compare against, and we can see how we're all doing. Vivek, and I know Colt takes the whole green network very seriously as well. We heard from your CEO only a month ago about her commitment to scope 3, for example, of the international measurements. We do have a role, don't we, in telecoms to reduce our customers' carbon emissions, but it's sometimes difficult to how we go about measuring it.
Yeah, well, absolutely. And I fully agree with my learned colleague who just mentioned the benefits about how we enable it. So absolutely, I would like to touch upon both the dimensions really. One is how do we take measures and take actions to save the carbon emission at our level, which means what we are doing in scope 1, 2, and 3. And we definitely have targets. So for example, within Colt, we have 42% of target reduction targets in scope 1 and 2, and 28% in terms of scope 3. But that's very direct, I would say. We also have the enablement, which my colleague just mentioned, because that's a huge dimension. It's difficult to maybe measure and really quantify the contribution that we are doing. But look at the kind of virtual world we are living in. The whole thing is online. The education sector is turned online. The transportation has changed. The aviation industry is suffering because of a lot of online meetings and conferences. There's just no sector which is not touched. The supply chain has turned a lot, very different world today. The supply chain, we don't buy retail. So retail clients are not hopping in the shops and retail outlets. They are all coming through your doors through a shared infrastructure. And the shared infrastructure is the key to actually enable reductions in the carbon emission. So we are, as a telecom industry, our solutions are enabling multiple different industries to save carbon emissions at their end. And that's why I say our direct contribution towards the reduction is one dimension, but the bigger dimension is how concrete services and solutions can this industry build for different sectors to enable them to reduce the carbon emissions. So absolutely agree. And as I said, there are some internal targets, and we do measure that. We can talk about it in more details. But the indirect one, contributing and enabling other sector, that's a little bit difficult to really track and measure. But I think the industry needs to do that quantification also at some point.
Yeah, absolutely. As you said, and it is digitalization of other industries is just accelerating all the time, especially in recent years. Now, can we look at the telecoms networks itself for a moment? Azeddine, if I can come to you now, are there some areas of telecoms that are less energy efficient than others?
Very nice question. Yeah. This is basically, we were talking about scope 1, 2, and 3. Basically, I wanted to say that we spent more than 10 years optimizing our networks. And now I think we have a good picture of what are the sectors that are consuming. So let me do it very easy. Basically, the consumption is at the edge. In our language, the edge is the access, the last mile to the user. Basically, in mobile networks, it's base stations, and in fixed networks, it's the central office that is just near the user. So it's basically the last mile or the edges. So the consumption is there. This is the most important part. It's evaluated about 70 to 80% of the total consumption, including only networks. I'm talking only about networks, without devices and without data centers. If we take into consideration, and we know it now, manufacturing and usage, we know today that for networks, basically 20% is consumed for manufacturing and 80% is consumed during usage. So we know two things. The consumption is at the edge, and second, the consumption is in the usage phase and not in the fabrication. I'm talking only about the networks. And the third response that I wanted to say is that geographically, geographically, if I can say it like this, consumption is basically in rural and suburban areas, while in dense urban and urban areas, we have, of course, we still have networks there, but they are very efficient because they are well used by our customers. However, in rural areas, we know that base stations are there, but most of them are used for coverage and not for capacity. So we know three things at the end. It is at the edge, first. It is at the usage phase. This is the second point. And the third point is geographically, more or less, it is in the 70% of the consumption is in the rural areas and suburban areas, more than versus dense urban areas. This is what I wanted to give you as a response for your question.
Yeah, thanks, Azeddine. That's good. Some very interesting figures in there. Saima, if I could turn to you about looking at specifically at the mobile network, and we were talking about the network itself and the consumption in the network, where we look at the network and the edge use of the network, the RAN is there. The RAN is a large share of the overall consumption. So as we move, say, from 4G towards 5G and more traffic moves over to 5G, how do you see the trend in upcoming years? And will the RAN continue to be the largest share of overall consumption?
I have to admit before I answer this question that it's a bit tricky. Why? Because let's look at in the beginning from the two different aspects. Let's look only from the mobile technology perspective, first of all. So we already know that LTE has been much more energy efficient as compared to the previous technologies, and lately we have also seen the evidence proving that 5G is actually 90% much more energy efficient as compared to LTE per unit of traffic transferred. So here, this is the highlighted part that I want to mention, that per unit traffic that is being transferred over 5G. From the standard perspective itself, 5G also has much more of an energy improvement. So it brings along many energy saving capabilities, especially when we look into the low to medium traffic options. So this is from the technology perspective that we can say about 4G and 5G. Looking at a different aspect of what these mobile networks will carry. So if we look at the moment, the data traffic which our mobile networks are carrying is around 300 times more than compared to a decade ago, according to a latest report from the Ericsson mobility report. And this is something which is only about the data which is carried. Now, looking from the devices perspective, the forecast is that in 2025, we will see around 100 billion devices, including 40 billion smart devices, and mobile network coverage will be somewhere going between 6.5 billion users. So if we look at all these aspects, so ranging from the data that the mobile networks are carrying to the number of connected devices, and then bring along the energy efficiency aspect, I think it will be a bit, it will not be fair to compare directly the two technologies, but it gives us an impression that we have an exponential rate of data increase in the upcoming years. And 5G is also being rolled out very fast, and we also see a higher adoption rate of 5G. So according to a research we have, at least I think by 2027, around half of the mobile subscriptions will be running on 5G. If we look at Germany, we at Deutsche Telekom, we have rolled out our 5G services already, and by 2021, we already covered 85 to 90% of the population here in Germany with 5G network. Also, not to forget that 5G network is also running on higher frequencies. Higher frequencies also bring along higher densification. So bringing all of these factors together, higher densification, new services, streaming, increasing digitalization, and all the things that we have heard before, what we are enabling, we do see that there is a higher growing rate of data which the mobile networks have to carry. And we as operators do need to work on this topic. And second of all, we need to understand that the implementation of 5G will play a key role in breaking this energy curve. So this is one of the biggest, I think, opportunities that 5G will bring along, that we will be able to implement much more energy saving features in the network. And then hopefully we will be able to keep the energy consumption stable over the upcoming years.
Great. Thank you, Saima. Now, Vivek, we've talked about usage going up, but it's not just mobile usage, it's fixed traffic as well, of course, is going through the roof. So how much latitude do you think we have in our industry to reduce energy usage? Are there any specific efforts that are underway at the moment to help this throughout the telecoms ecosystem? Not just the network, but also component design, manufacturing. There's a lot of, the ecosystem is long, and this supply chain is also long. So I guess there's a lot of scope to make changes for the better.
I fully agree. I think there is it's in our control to a large extent. Also, it is our responsibility that we as telecom service provider need to constantly do few things. And the first one, for example, is utilize the technology in this sense, because you push your manufacturers. There's always a saying that manufacturers will manufacture what the user will buy. So as a provider, we are also user of the equipment and the technology. So we need to constantly push our manufacturers to produce more efficient technology, and they are capable of doing that. We've seen that in the last couple of years. The new technology is much more efficiency. It is much more efficient in terms of the ability to do the data transfer compared to what the energy is consumed in it. We just heard about a great example of 5G, but that absolutely applies to almost all the technologies, especially in the telecom sector. I can give you a few examples. Like, in 2017, Colt deployed a new greenfield network. It's high bandwidth capacity network, which was called IQNet internally. That IQNet network used the equipments which actually in a couple of years of time have brought in around 82% of power saving compared to the previous models and equipments. That's a massive one. It also brought in 88% saving on account of the space required to put those equipment. So massive enhancements are possible because of technology enhancements. Massive saving is possible because of technology enhancements. The provider need to make constant effort to deploy them, adopt them, and also push the manufacturers to constantly create them. So that's one example. The second is we also need to look at how constantly can we remove the legacy platforms and systems from our network. Again, a great example that Colt has undertaken. It's a massive investment opportunity, but it also gives massive returns, because the SDH and TDM, for example, was legacy platforms, and I'm sure if you recall, those platforms were massive, the really massive even technology running in those boxes actually needed a lot of power. All of that, the whole voice network is transformed and is able to sit in a kind of virtualized environment, which we call it as VoIP network. So through the transition from SDH, TDM to the VoIP and more enhanced Ethernet versions, we are actually capable of looking at reducing within Colt, as an example, around 100 gigawatt hours by the end of this project. So we will be looking to remove those legacy massive boxes. That's another second thing. Similarly, constantly optimization opportunities. How do you consolidate? Because if I give you one stat, uh, the telecom whole energy consumption, approximately 85% of energy is not really used to transfer the data. Only 15% of energy is used while actually transferring the data within the telecom network. It's a very disturbing figure, because it essentially means that 85% of energy is used in an ideal time when the data transfer is not happening. So that kind of gives us an opportunity to see that how can we reduce those idle times, how can we have those boxes removed from the systems or the platforms or the network, which are not really being put to the right use. So internal efficiency, optimization opportunities, removing the legacy platform, adopting new technology, enhanced versions, these are, I would say, in the remit of technical, and that's what engineering department, for example, in Colt is taking up. So that's a technical stream. Other than that, I would also say, Guy, that we all need to be sensitized about these things. We all need to be talking. I think you do great service in bringing this platform and the discussion together, because we have science. I mean, we have science-based targets introduced. There are bodies that are coming up. It's not easy to bring about regulation alone, and we need to sensitize. So, for example, Colt has been participating in various forums and discussions. We also did participate in the COP26 in UN DEFRA climate action conference. We also have adopted science-based targets, as I said earlier. So we're looking at new sustainable procurement policy, so that we also have a full control on the downstream companies and platforms. We will also be looking at building an in-house net zero standard. How do we reach to that? Our roadmap for that, and I mean various measures about sensitizing internally as well as externally, I think is the need of the hour, and this is a great example, I would say. So yeah, definitely, I think we have responsibility as well as significant leverage at hand to kind of turn the needle.
Something we haven't heard about yet in our discussion, Saima, I'd like to come to you with this one, is AI, and whether or not AI can play a role in all this. Is AI more of a hype, or do you actually see practical benefits in how we can use it to reduce our energy consumption? Are there any challenges associated with this approach?
So we already heard multiple times in this conversation about the exponential growth of data, and of course the increase in energy consumption which comes along. Tweaking some static parameters into our network, or bringing an energy efficient hardware with powerful chipsets, for example, will help us definitely to reduce the energy consumption. But I think it will alone not be enough, because we do need to understand that the growth of the data rate and the higher traffic volumes will, of course, as an operator, for us, it will be very important to make sure that we have the best quality network despite all of these challenges. And I think this is exactly where AI or automation can help us, can help the operators to bring along the efficiency which is required to maintain such a network. And I also do not think that AI can support only in the radio access network, but I think across the whole network. So in terms of managing and allocating, for example, resources efficiently, also helping us to optimize the shutdown modes, which Azeddine was previously talking about, to optimize the parameters in a way that the network is consuming energy when we have the load, and in low load conditions, we either put the equipment into the idle mode, for example, or they go into hibernation. 5G is also coming along with advanced sleep mode, so the activation of all these features could be heavily supported by the AI if AI comes along. Apart from the basic shutdown features which we already have and which we are implementing, I think that several other options which AI can also help us to become more efficient could be, for example, the intelligent beamforming or the better utilization of a spectrum, even reducing the site visits. And I think that with the help of AI, we can overcome many challenges which we have at the moment. But introducing AI in itself could also be a challenge, and this could be one of the reasons why we don't see a very high rate of global adoption of AI at the moment from the operator side. One of the things which we have also touched upon here in the discussion is our dependency on the vendors. So what equipment our vendors are bringing and how they are enabling us to implement the energy saving features. And on top of that, we are operating the multi-vendor environment, and we do need to build skills in our companies to make sure that we are able to leverage the data that we have and bring out some actionable insights out of that data, because energy management in itself and energy optimization is a very data intensive area. So artificial intelligence could definitely support to bring some clearer insights for the operators to help us understand where exactly what potential lies in the network for energy savings. So we as operators are also working together with our vendors to make sure that our networks become much more intelligent in the upcoming years, and AI will definitely play a huge role in making our networks much more intelligent.
Great, thank you very much, Saima. Well, we are out of time, unfortunately, and it's very clear during our conversation the past 35 minutes or so that it's so important that we're able to measure the energy efficiency of our networks, but we've got to get our facts straight. We've got to know what we're measuring. We've got to compare like with like, and there's a lot of ideas there's a lot of projects in play, but there's still a lot of scope and a lot more we can do as an industry, and we will follow up on these throughout this summit. With that, we must draw our discussion to a close. So thank you all very much for participating and sharing all your views. And if you're watching this on day one of the TelecomTV Summit on the Green Network, then please send us your questions and we will answer them in our live after show program. And that is later today. And please do take part in our online poll, which you can find below this video player window next to the Q&A app. For now, though, thank you for watching and goodbye.